Hey, everybody, and welcome back to the Rule Your Pool podcast. I'm your host, Eric Knight, doing this one alone simply for scheduling reasons. That, and as you're going to hear, this is probably the most complex Rule Your Pool podcast episode we've ever done. And it's quite advanced chemistry. Although anybody who's taken a chemistry class probably learned this in their first year of chemistry, but we just forget about it because this is not something we would talk about all the time. But it's important that we cover this baseline lesson to get to the real question that we're trying to answer in this episode and several questions going forward. This is a question we've gotten a lot of in the past few years. And honestly, I've been dreading doing this because I didn't understand it. To be honest with you, I still don't fully understand it. And I'm going to try my best to simplify this down and explain it to you in a way that can be understood. If you get lost, I'm right there along with you. I'm sorry in advance. I'm doing my best here. So if you're a chemist listening to this, if I do misspeak, it is not intentional. It is just in the interest of getting the information out and simplifying it down into something practical so that we can actually apply it to our swimming pools. This episode has 6 pages of show notes. Not that Jared would read them anyway, but that's really why he's not on the show. He would bring absolutely no value. That he much to begin with, but it's okay. We can talk about Jared behind his back because he doesn't even listen to the show. He doesn't. And Catherine, I'm sorry my voice is putting you to sleep. Wake up. You're going to learn something today. All right. In this episode, we are going to answer the question, what do product percentages mean? You know how you get like a bucket of chlorine or a gallon of liquid chlorine or several other products, maybe calcium chloride, and there's a percentage on there. For calcium chloride, it's 77% or maybe up to 80%, or maybe you have Prills and they're 94%. What does that mean? Cal Hypo is a classic, or trichlor, or dichlor, or even liquid chlorine. There's always a percentage there. Trichlor says it's 99%. Does that mean it's 99% chlorine? Or is it 99% trichlor compared to something else in the bucket? Or maybe it's a weight percentage, or maybe it's an available chlorine percentage. That's what we're going to answer today. And in order to do that, I need to dive a little bit deep into understanding a standard unit of measurement that is going to answer all these questions. And I'm going to warn you right now, this episode is math heavy. I'm recording this before the end of the year. I have not yet written this out in a blog or in a help article at ask.orendatech.com, but I will. It's just going to take probably, at the rate I'm going, several weeks, maybe even a month. But eventually we'll get this written down because I want to get this content out before trade show season. This is a big topic. And before getting into this break, full credit for this episode goes to our man, Richard Falk, the chemist guru that we cite so often. He is very helpful with this, and he's the one who explained this. And then I went down the YouTube rabbit hole. I went down through peer-reviewed journals. I have probably spent 10 hours researching this. It all started from his email answering this question, and he gave me some sources. So, Richard, if you're listening, thank you so much. I hope to do justice to what you've taught. And I verified it. It's not just from Richard. I've gone on PubChem. I've gone on all sorts of sites. What he said was right. And we're going to do some math today, or I'm going to do some math, and you're going to listen against your will because this is a tolerable podcast and we're going to learn. We're going to learn today, whether you like it or not. So anyway, this is episode 131. Let's get right into it. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Now, in order to understand product percentages, we have to first go back to molecules themselves, to the periodic table of elements. And we need to first know, how are these things measured? Because an atom is really, really small, not even microscopic. It's so small you really can't see it. So if you're going to do an experiment in a lab, it's not like you can just interact 2 hydrogens with 1 oxygen to create a water molecule. There isn't a spoon small enough to grab single atoms and interact them. It's just not going to happen, right? So we need to have large quantities of these atoms so that we can actually convert them to a unit of measurement that's practical, something that we can actually handle, And it takes a lot of atoms to create enough of a substance to create a physical reaction in a lab. So there's a new unit of measurement. Well, I shouldn't say new. This has been around for a long time, but it's new to me. because I'm not a chemist. I don't pretend to be a chemist. It's a unit of measurement that allows us to bridge the gap between atomic weight and actual weight, like actual mass that we can measure and handle. And that unit of measurement is called a mole. And before I get further than this, if you're thinking of Austin Powers and Goldmember, where he's poking the mole on that guy's face, that's what I was thinking too, but it's actually MOL. And I guess some people spell it with an E. There are some sources that go either way. But a mole is a unit of measurement of a huge amount of atoms, but a very specific amount of atoms. And then when you have that very specific amount of atoms, it's heavy enough that you can weigh it. And you will then get a unit of measure that says grams per mole. So technically, I'm going to quote here in my show notes, according to the Journal of Chemical Education, a mole is an amount of a substance. It is exactly 6.02214,076 times 10 to the 23rd power number of molecules or ions or atoms. That is a huge number. And I can't even tell you, it's not billions, it's not trillions, quadrillion, quintillion, bazillion, gagillion. I have no idea, but that's a lot of zeros. 23, 10 to the 23rd power. So we're talking a lot of atoms. And when you have a mole of whatever this substance is, whatever this element is, you can weigh it and you can convert that to grams. And so the measurement would look like grams per mole. And it looks like G/MOL. And that is a molecular weight converted into an actual weight that we can handle. So when you start seeing things, when we talk about available chlorine or weight ratios of the actual product, we need to know the molecular weight of the substance. And then to find out the active chlorine in that, we have to compare that weight to the weight of elemental chlorine. And this is all done in grams per mole. Then we can figure out percentages and molar ratios and all sorts of stuff. And that may be in a future episode with a chemist, but it ain't going to be here. Not today. I'm just going to overview this. I'm going to read some numbers. I'm going to try to get through this in a way that is understood. No promises because it is complex. So buckle up, Buttercup. Here we go. So remember, a mole is a huge amount of a very small substance, atoms, ions, molecules, whatever, but it's always the exact same amount. This very highly specific number of 6.02214,076 times 10 to the 23rd. Yeah, it's a lot, but it's always the exact same amount. So where did that come from? Well, this is also known as Avogadro's number. And when I first read it, it looked like avocado, so I'm going to stick with that. Avogadro's number. That very specific number is the exact amount of carbon atoms in 12 grams of carbon. So that's the standard. It's all based on carbon. So when you have that exact amount of atoms, you'll have a different weight than carbon, of course, but you'll have the exact same number of atoms or ions or molecules. And this is how we get molecular weights. That is the standard. Sounds crazy. It may have made more sense to just say a million or a billion, but no, this is how it's done. So we are going to convert this to, we're basically bridging the gap between being able to measure something physically or theoretically. And that's what we're doing here. And in order to do that, we need to know what a substance is actually made of. And when we know what the substance is, thanks to the internet, we can go on something like PubChem or Wikipedia or just Google it. And all of this is available. You can find out the exact molecular weight of any substance. It's all public information. It's pretty cool. So I went on PubChem and I checked Wikipedia too. Sure enough, it's the same number. 1 mole of a chlorine atom is going to be 35.453 grams. So the number is 35.453 grams per mole. Now that's Cl. That's a chlorine atom, not a chlorine gas. Okay, chlorine gas is Cl2. So you double that and it goes to 70.91 grams per mole. Now let's look at the common products that we would see. And this is where the percentages come in. Everything that you're about to hear is relative to what I just said. It's relative to the weight of elemental chlorine. Okay. Trichlor, its molecular weight is 232.41 grams per mole. Sodium dichlor dihydrate, now there is an anhydrous, by the way, which is a different product that's not sold in the industry. This is dihydrate, is 255.98 grams per mole. Cal hypo is 142.98 grams per mole. Sodium hypochlorite, liquid chlorine, bleach, is 74.44 grams per mole. Now, if we get out of the chlorines and we get to products like calcium chloride, if you use the Orenda app and you are dosing calcium chloride on a startup, let's say, you're going to get two results. One is calcium flake, 77 to 80%, depending on the purity. And the other one is prill or granular, which is 94%. That's the same idea. We're going to take this substance and we're going to know that the molar weight of calcium chloride is 110.98 grams per mole. Or we have calcium chloride dihydrate, which has two waters bound to it, basically, and that is 147.01. Now, I could go through all this. I got sodium bicarb, potassium monopersulfate, hydrochloric acid, all these things. I don't want to get lost in the weeds. I don't expect you to remember the numbers. You can Google them yourself. What I am going to do is reference these as we go through some math to figure out what do these percentages mean. So let's get into that. Let's start with trichlor tabs. Trichlor is labeled as 99% trichloro S-triazine trione. I hope I said that right. That 99% is not active chlorine. That 99% is a weight percentage of the product, meaning whatever this substance is in this bucket, 99% of it is this substance called trichloro S-triazine trione. Whatever else, maybe it's binding agent or filler, I don't know what it is, but 99%, that's exceptional. That's very pure for whatever this substance is. But what is this substance? Okay, let's dig into that product. And now let's see what's actually in trichlor. Let's look at the weight of it versus the active chlorine. And remember, an active chlorine is going to be compared to the molecular weight of elemental chlorine. So let's do some math. The available chlorine in this product is a weight percentage of the chlorine content relative to the elemental chlorine gas, which is defined as 100% when we're doing this. Elemental chlorine, just the atom, is 35.453 grams per mole. Now, these are not chlorine gases connected to trichlor. These are just chlorine atoms. All right, so they are at 35.453. Multiply that by 3 because there's 3 of them, and you get 106.359 out of a total grams per mole weight of trichlor, which we said earlier is 232.4. 106.36 is about 45% of the molecular weight of trichlor. So by weight, about 45% of a trichlor tab is chlorine, and the other 55 is going to be cyanuric acid and other things, maybe salts and stuff like that. So think about that. You're holding an 8-ounce tab. Less than half of it is actually chlorine, physically. We all think it's a chlorine product. It's actually more of a cyanuric acid product. Yeah, it was 99% on the bucket, but only about 45% of it is chlorine by weight. Okay, but that's the catch. It's by weight. Percentage-wise might be a little bit different, and here's where we get into it. The available chlorine is a different percentage than the weight percentage. Since molecular chlorine results in only one active chlorine, okay, because Cl2 goes into the water, you create HOCl and HCl, we have to multiply the active chlorines by 2 to convert it to Cl2. Now we've got 2 times 106.359, which is 45% of it, but now we double that 45%, and we get to 0.915 or 91.5% for pure trichlor. But we don't have pure trichlor. We have 99% trichlor in the bucket. So 99 or 0.99 times that number leaves us with 90.6% active chlorine in trichlor. If you're not confused yet, you haven't been paying attention. I've gone cross-eyed, so I'm doing my best. So we got 3 different numbers for trichlor. I guess that's convenient because it's called trichlor. We've got the weight percentage, which is about 45% of this tab is actual chlorine. We have the active chlorine percentage, which is 90.6%. And we have the product percentage, which is 99% product in that bucket. Wow. But if you understand grams per mole, and all of this is open source information, you can do some math and figure it out too. And we will write it in our website eventually. It's just going to take a while. So let's move on to dichlor. Dichlor is labeled as 99% sodium dichlor S-triazine trione. Again, this is a product percentage. This is a weight percentage of what's in there, just like trichlor. And technically what we're talking about is sodium dichlordihydrate, which has 2 water molecules bound to it. And the reason, according to Richard, is sodium dichlor anhydrous is really not sold because it's more hazardous and it would require special packaging. And anyway, the one that you get in the pool business has 2 waters in it. That molecular weight is 255.98 grams per mole. So now if we do the math, and I'm just going to shortcut this, when we do the multiplications to get the chlorine in this product, it comes out to about 55.4% available chlorine. But again, that's assuming that it's pure sodium dichlordihydrate. It's 99%. So we had to take 99% of that, which takes us down to 54.8% available chlorine. Now, there are some manufacturers that say 56%. That probably has some anhydrous in there. I don't know exactly how that is, but according to the molar weights and ratios that we see in open source information for these substances, it should be 54.8%. But it is entirely possible that some of it is anhydrous, and that's probably what's in the bucket. I don't know. We don't make dichlor. And frankly, I've never used it, so I don't know. So now we know the product percentage is 99% in the bucket, and we know the available chlorine is 54.8%. But let's look at the weight. We'll do some more math there, but it comes out to 27.7%. Think about that. That's less than a third. It's about a quarter of it, really. I mean, 25% would be a quarter. We're at 27.7% of sodium dichlordihydrate is actual chlorine, which leaves the rest of it as something else. So we did some more math. Cyanuric acid is 49.2% of the substance. The 2 water molecules that are connected, because it's dihydrate, is 14.1%. And then sodium is 9%. And all of that adds up to 100%. So really, sodium dichlor is only about 27.7% chlorine physically. But the available chlorine is 54.8, not 99. Let's move on. Cal hypo. Now, this one is super confusing. We get far more questions about cal hypo than any others. And I want to be very clear. There are 2 cal hypo strengths, and each of those strengths can be labeled 2 different ways. This is why there's so much confusion. There is 65 to 68%, and there's 70 to 73%. If you look on our app, we offer both. Here's why there's 65 or 68, and then there's 70 or 73. One of them is the weight percentage. One of them is the available chlorine percentage. That's why. And it just depends on how the manufacturer decides to label it. So let's do some math. Cal hypo, when compared to the molar weight of chlorine, would be 2 times 2 times 35.453. You take that, you divide that by 142.98 because cal hypo's grams per mole weight, molecular weight, is 142.98, and you get 0.992 or 99.2% for pure cal hypo product. It's a very strong chemical, and what you actually get in the industry is 68% or 73% of that. So if we are going to go by weight percentage, 68 is a weight percentage. So if we take 68, 0.68 times 99.2, it takes us down to 65.52. So you want to be conservative and you say it's 65%. Amen. That's the right way to do it. So that's what that means. You could do the same math where you take 0.73, which is 73 weight percentage, times 99.2. It brings you down to 70.6. That's why it's labeled as 70. That's what that means. If you see a percentage, see if it says by weight or if it says available chlorine. When you look at cal hypo, the lower of the 2 is the available chlorine, the higher of the 2 is the weight percentage. But apart from that, it's a very strong chlorine and it does what it does. Keep in mind, none of these products should ever mix. We've beat this dead horse enough, but I'm going to beat it again in case this is your first time listening to our podcast. Never, ever, ever, ever let 2 different chlorines touch each other. They do not play nice. They can be fire hazards, explosive hazards, all that stuff. So be safe. Keep them separated. Absolutely. Don't worry, I won't play the song again. Okay, now let's get to our bread and butter. Our parent company is HASA. HASA makes liquid chlorine. Sodium hypochlorite, bleach. You actually have 3 ways to measure it. You have the weight percentage, just like you did with dry. You have the available chlorine percentage, just like you did with dry. But now you have something else. Because it's liquid to liquid, you have a trade percentage. A trade percentage is the easiest because it's just converting directly into a pool, right? So a trade percentage is how it's labeled, and that's what we know is 12.5% or 10%. Or if you're using household bleach, it's going to be 6% usually, maybe 5.5%. That's a trade percentage. Dry chemicals are measured by mass, but liquids are measured by volume. If you look at our calculator and you make some chemical changes that you want to do and you get recommendations, you'll see a disclaimer at the bottom on our calculation results page that says you're measuring dry by weight or mass, and you're measuring liquid by volume. If I've got a liquid measuring cup and I put 10 ounces of water in there, it will also be 10 ounces of milk if I put that in there, or 10 ounces of cooking oil, because liquids are measured in volume. It's the same volume of stuff. Now, they will all weigh different. I mean, 10 ounces of PR 10,000 is a lot heavier than 10 ounces of water, but we're not measuring in weight for liquid. We're measuring in volume. Dry chemicals are the opposite. Dry is going to be measured in mass or weight. So when you are measuring chemicals out, don't use a liquid measuring cup for a dry chemical. It's not the same thing. They actually make these custom molded measuring cups for dry chemicals in the pool business. You can get them at distribution, retail stores, and they have graduated lines for different products. 1 pound of Cal Hypo is a lot less volume. It looks like less material than a pound of DE or a pound of sodium bicarb. They all have different volumes, but we're measuring the weight. And because we're measuring by volume for a liquid, we can have a trade percentage. So here's how it goes. 1 gallon of 12.5% liquid chlorine, that's the trade percent, is an easy calculation because in 10,000 gallons, that equals 12.5 parts per million. Here's why. We're going to take 12.5 divided by 100, and then we're going to divide that by 10,000 gallons. Well, that's no different than multiplying 100 by 10,000 and saying 12.5 divided by a million, meaning 12.5 parts per million. That's why it's an easy thing. So a trade percentage is great if we're basing it off 10,000 gallons. That's how we figure out our parts per million. The same would be true for a trade 10% liquid chlorine. If you put a gallon of that in 10,000 gallons of water, it's going to give you 10 parts per million instead of 12.5. Now, we could do the math if you want. Let's do the weight percentage and available chlorine. The equivalency looks like this. All three of these equal the same thing. The weight percentage of available chlorine equals the trade percentage divided by the density, which is also the same thing as saying the weight percentage of sodium hypochlorite times the molecular weight of chlorine gas, Cl2, divided by the actual molecular weight of sodium hypochlorite. You get all that? Don't worry about this. Here's the bottom line. Our app does all of this for you. Everything I've talked about, all these molecular weights, all these percentages, when we give you recommendations of chlorines or calcium chloride flake versus prill, sodium bicarb, all of the math is already done. All of this is factored in. So when we say we have a precise calculator, we're going to 6, 7, 8, 9 decimal places. That's the truth. And in our formula, we're using actual moles, which go to 10 to the 23rd. Think about the precision in that. We're not just using a dosing chart, people. We're looking at the actual product percentages as they are labeled and specifically getting into the molar weights and ratios of what they're doing in water. We wanted to be precise. And we had a mission when we were developing this app that this was the most precise calculator in the world for water chemistry. That's no joke. We wanted it to be the undisputed. Maybe someone matches it, but no one could possibly be more accurate than ours. We didn't do it alone. We're very grateful for the help that we've had, but this is just a taste of what's going on behind the scenes on the Orenda calculator. Now, that is completely dependent on the inputs you give it, because a calculator doesn't know if you're telling the truth or not, or if your test kit is accurate, or if you're using cold water like we talked about in a recent blog. Maybe you're testing a sample of water that's 42 degrees and your reagents can't react right. Well, that's not going to be an accurate reading, maybe. And you put that in the calculator doesn't know that. It's just doing math based on what you tell it. So it's contingent upon you having accurate test readings and an accurate pool volume. Because if you think your pool is 15,000 gallons and it's actually 17,240, it's not going to be very precise. So keep that in mind. The more precise you can be with what you input into the calculator, that calculator is going to have your back because it's factoring all of these percentages in for you. Now, let's wrap this up. It's important to understand that just because you see a percentage on a product that may be higher or lower than something else, that doesn't necessarily mean it's a less effective or more effective product in the water. You're putting this chemical into the water. What does it do when it gets in there? Any type of chlorine is going to eventually create hypochlorous acid and hypochlorite ion. Every single type of chlorine is going to do that. It's also going to create hydrochloric acid. What differs about the chlorine types is the byproducts they leave behind. Calcium hypochlorite, it puts up calcium, also some salt. Trichlor leaves behind CYA, and it leaves behind some salt. Liquid chlorine only leaves behind salt. But the point is they all leave behind something. Every single one of them will accumulate some TDS, total dissolved solids. And it's just a matter of what you want to manage over time. It would be a fallacy to say, well, because this product has a higher percentage, if I just take the exact same weight of that and put it into the pool, I'm going to have the same amount of chlorine. Nope. Absolutely not true. And when you look at the Orenda calculator, when you do chlorine doses, you will see exactly what I'm talking about. Do it right now if you're not driving. If you are driving, don't do it. Catherine, stop listening to the podcast while you're driving. If you're not driving right now, go to the calculator, put 0 chlorine on the left, and go up to, say, 4 parts per million, which is the EPA limit as it stands today. That may rise over time, but as of now, it's 4. 0 to 4 parts per million. Calculate. Then you'll see a toggle at the top that shows cal hypo, liquid chlorine, and dichlor/trichlor. Take a look at what those numbers are. And what we've added into the app is we show the byproducts that are left behind. For instance, if you put in liquid chlorine, it's going to show you that it increases the TDS or the salt by X parts per million based on your dose, based on your pool volume. Same thing for cal hypo. We show that it increases CH, which is calcium hardness, and you can tap that hyperlink to learn more about it. And the same thing with dichlor and trichlor. They're stabilized. How much CYA do they leave behind? I'm going to leave you with this. In order to understand these chemicals, we need to know what those percentages actually mean. And we needed to know what that product meant based on a molar weight, grams per mole. I hope I said that right. I probably screwed something up along the way. It was not my intent. I hope this was a valuable lesson for you. This lays the groundwork for some more in-depth chlorine talk that Terry and I are going to do over the next several months. We do have trade shows coming up, and I do want to do a little bit of housekeeping before I end here. The trade shows in January, the big one is the Northeast Pool and Spa Show in Atlantic City. And we're going to do something cool on that one. Most of what we do, whether it's this podcast or our blog, is aimed at helping homeowners and pool professionals rule their pool. Not cliche. I mean, it's legit. That's what we want you to do. We want you to be able to go in and treat water the way water wants to be treated so that it can behave and you can have success with it. But part of the success that we teach with pool pros, these are our core customers here. We want you to take pride in what you do. Don't look down on this profession. Being a pool pro is not an easy job. You have to have a lot of skills. I mean, think of another job where you need to be good at electrical work, or at least decent at electrical work, plumbing, chemistry, and you got to work outside and clean things. It's a lot. It's a hard job. Take some pride in that. In Atlantic City, we have hired a professional photography company to give you free headshots for your business. You sign up ahead of time, or you can come to our booth and sign up, be there on time. Think ahead before you come to this show. Bring a clean company shirt, maybe get your hair did, whatever it is for you, company hats, whatever it is. Come there and you will get a professional grade headshot for free on us just for being our customer. We will be there at some point trying to record a podcast, but to be honest with you, I don't know if that's going to happen, but we're going to try. We would love to see you in the booth. I will be teaching classes. One is stop servicing pools, start servicing people. The other one is practical water chemistry. And the third one, it actually happened before the show, is the Water Shape University Essential Plaster class, which I also taught in Vegas. Really looking forward to that one. It keeps getting better and better. Miguel Chavez is going to be teaching those same 2 classes, not the Water Shape ones, but the other 2, in Spanish. His Spanish is much better than mine. I'm not so sure about Jared's, but I think it's better than Jared's too. But yeah, Miguel's a great teacher. So if you have Spanish-speaking employees, I encourage you to put them in those classes. It's going to be a lot of value, specifically for pool pros, and we hope to see you there. One final note. Yeah, you know what? I don't think there is a final note. I had it. It was on the tip of my tongue, and then I forgot it. But if it comes up, we may do another episode. This is probably the last episode of the year. I don't know, but it's December 15th today, and I'll probably have this edited in about 3 or 4 days. It takes a whole bunch of time. I want to tell you again just how grateful I am for all of you. It really warms my heart, the amount of emails and phone calls we get in response to certain episodes that something that we said changed everything for you guys, or it was a breakthrough or an aha moment. I love that. And if this is the last one of the year, it's been a crazy year. Personally, of all the years that I've been at Orenda, we had the best job in the world. I mean, we got to have so much fun doing this, building this brand, creating this tolerable podcast, writing all these blogs, visiting so many customers, teaching classes. And I was so concerned when Hasa bought us that our culture was going to die. I'm just being honest with you, because we've seen it so many times when big companies acquire small companies. People just lose their motivation and it just goes downhill. And I'm here to tell you that didn't happen. When I'm telling you that Hasa is making changes, they are making changes. And you're going to see them in 2024, as evidenced by the things I say on this podcast. So, if anything, we're doubling down on the Orenda culture, steering this ship in a new direction for a bigger company, and they are all about it. You are about to witness a revamping of Hasa. I'm very happy to be part of it, and I want you to know that the education will not stop. We will be pushing the gas down. We love you very much. Have a wonderful holiday season. Have a Merry Christmas and a Happy New Year. I'm Eric Knight with Orenda. This has been episode 131. Take care.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.